Good morning, everyone. Happy Friday. Finally, the sun is out. So, just want to let you guys know that Miss Minion will not be joining us today. So, if you are writing on the chat anything, she will not be able to reply. So, if you have any questions, either you can stop me while I'm teaching or you can ask me after the class. By the way, anyone has any questions? So your test two is graded, but still there is one student that has made a passing because of that dean's permission. So most probably I will release the test tomorrow. So far the class average is 86%. Most of you did pretty well in the test. Anyone has any questions for me regarding the test? We will talk about that in Monday's class once everybody is done. All right, so we are going to start chapter 5 today. And chapter 5 is not too long, but again, it is a very important chapter. We are going to talk about few things in chapter 5, but not in too much detail. So chapter 5 basically gives us some introduction that we are going to do in chapter 6 and chapter 7. And obviously, chapter 5 is built upon our previous chapter 1, 2, 3, 4. So in chapter 5, we are going to talk about sampling distributions. And so far, we talk about two distribution, normal and uniform. In this chapter, we are going to talk about two more distribution. One is binomial distribution and one is Poisson distribution. We are going to just touch the Poisson distribution. We are not going to do that in detail, but we are going to talk about binomial distribution. What is binomial distribution, where it is coming from, and why do we use it? And again, when we are talking about distributions in chapter 4, we talk about that when we work with continuous distribution or discrete distribution, how do we find the corresponding probabilities? So same thing when we are going to talk about binomial distribution and Poisson distribution, we are going to find the probabilities of particular events depending upon what event or what scenario or what conditions are given to our binomial distribution or in Poisson distribution. So we will discuss that. But again, binomial distribution and Poisson distribution we will do in the next classes, or you can say the next week, Monday and Wednesday. So this chapter, we will be able to finish this chapter in 3 classes, like 2.5, or at the most 3 classes. It will go a little slow when we talk about the distributions. So the good part for binomial distribution in Poisson is like once you understand how to do that or what is the procedure, why we are doing it, we have binomial tables and we have Poisson tables. Then you don't have to do the manual work. You can just look at the values from the table, like how we use table A, how we use table B. And also you can use calculator, like how we look at the normal CDF. Same thing, we can also find binomial CDF, binomial PDF. But the whole point is, if you understand the concept, the part is, or solving, finding the probability part is not hard. So let's start chapter 5, sampling distribution. So this chapter has 3 topics, 5.1, 5.2, 5.3. So instead of making 2 homework, there is only 1 homework on chapter 5 and there is 1 quiz on chapter 5. Both homework and quiz is open now, so you can start working at least on the homework, though we will not be able to finish everything today, but you can start working on that. And also, I think I mentioned a couple of times in this class that I'm assigning some statute videos on your launchpad for each chapter. So make sure if you have time, watch those videos for each concept. And those are not very long videos, they are just 3, 4, 5 minute videos explaining the concept with the example as well as how to use the calculator to do that particular problem. So whenever you get a chance, watch those videos. You don't have to watch all of them. Let's say we work on central limit theorem in this chapter or law of large number in the previous one, which we are going to use here also. So you can watch those 3 minutes or 4 minute video and they will give you the example. They are explaining. We are going to do the same thing here, but with the time limit, we cannot do too many things or too many examples. We still have three more chapters, or like we can say two and a half more chapters after chapter five. So watch those. In those uh, short statutory videos, there are questions, 2 or 3 questions in the middle or in the end. Just work on those questions. And again, when you watch those videos, make sure you take notes on the side because then you will see those questions. And again, if you miss those questions, let's say you get zero first time, you can attempt it again, or you don't have to attempt because that is not a part of your grade. That is just for your practice. So even if you miss those questions, you still can watch the video. But sometimes those questions are in the middle, like if it's a 3 minute video, you watch 1.5 minute video and then they have two questions. So until you answer those questions, it does not let you move to the next part of the video. So if you understand, then just go and fill the right answer. For some reason, if you do not understand, you can pick any answer choice and move on, or go back and watch the previous video again and then answer those. So that is one thing for I'm assigning for each chapter. And even if I don't assign, you can still see that on your launchpad. Each chapter there are statutor videos. If you want, I can show it to you guys. So you guys can see my screen where you can see the launchpad. Can you guys see that? Can one of you tell me?
Yes.
Okay, thank you. So like how you see here, there are these are assigned to you guys. So if you go there, here, for each unit, there are a couple of, and here you see 5 points, 5 points. So this I will make it to zero. Uh, so you will not be graded, or you can say that you will be graded, but those grades will not be counted towards your actual grade. And that is for each chapter. And I will suggest you to work on those videos like when you do your final exam practice or review. And there are other resources like that you can get, you have access to those resources when you go to your launchpad. All right. So in chapter 5, we are talking about how we do statistical inference, just a little bit of that, and we will do more on the inference part in chapter 6, 7, and a little bit in 8. The sampling distribution of a sample mean. So when we are talking about sampling distribution, what is that? And when we are talking about sample mean, we know what a sample mean is. And in last chapter, we also learned that when we increase the sample size, sample mean get closer and closer to our population mean mu. So sample mean we denoted with this, and population mean with mu, or you can say this. So in this chapter, we are going to talk about what is parameter, what is statistic, what notations we use for parameter. Is sample mean a parameter, or is population mean a parameter? Which one is statistic? Because when we do statistical inferences, then we do not use the word sample mean or population mean, population variance. We just use these symbols. And what are these symbols? Are these population? Are these samples? Or statistic parameter? We will talk about that. And then we will talk about Townsend proportion. So 5.1, we are talking about these important concepts, and sampling variability. We kind of covered that in earlier chapters, but we will go over this too. Bias and variability, we covered that in chapter 3. Chapter 4, we are talking about how to eliminate bias. We work with three principles of experimental designs. So we are just going, whatever our previous knowledge in chapter 3 and 4, we are going to use that previous knowledge in this chapter. And that's why this chapter does not have too much information, but we are combining what we have learned so far and then using that as if my distribution is not normal, how can I work that as a approximately normal distribution? So sampling from large population, that's all we are going to learn. So parameter and statistic. When we are saying parameter and statistic, parameter comes from the population. And statistic, when we work with the sample, the results that we get from the sample, we call them statistics. And again, when we work with the population, big picture, like how we learned earlier, we have population. Let's say this is my sample space, and this sample space represents my population. And I'm talking about collecting a small part, which is called my sample, and I will work on that sample, get the results, statistic, and use this statistic to talk about my population parameter. So let's look at their definitions. So here say, as we begin to use sample data to draw conclusion about a wider population, we must be clear about whether a number describe a sample or a population. Because population you are working with, that's what you are trying to estimate. When we are talking about parameters basically the characteristics, or you can say the parameters that describe the characteristic of your population. And when we are talking about statistic, basically statistics are the numbers that come from your sample. So when we say population, most of the time population is unknown to us. So we work with the sample. So like how I said that we have a bigger population, and let's say this is UNCG, and we are taking a sample from this, and then we are working on this sample. Let's say I get the sample mean, sample standard deviation, and all that stuff, and we get the results. So we use those results and do the conclusion based on those results or those statistics that we get using the sample. We use those statistics to talk about our population. So again, when we are taking the conclusion on the basis of the results that we get from the sample, so that means we need to be very careful when we work with the sample, because how we are taking that sample, and if we are not taking it in a right way, our sample suffer from bias. And if our sample from suffer from bias, our statistics suffer from bias, and that will not give us the correct or estimate for our population parameter. So again, back to chapter 3, how we can eliminate bias from our sample. We talk about it that we do random sampling. And we learn different ways of doing random sampling, simple random sampling. We talk about stratified, multi-stage, and you guys just had the test for chapter 3 and 4. So I'm hoping that everything is clear. So when we are talking about random sampling, again, in statistic, if you notice from the beginning, we are just talking about randomization. So again, a randomization is a key, or it is very important in our sample or in statistic, because that eliminates the chance of bias. And our goal is to reduce as much as bias possible. So when you reduce the bias, then you can use those statistics, and then you can talk about the inferences or the conclusion. Use those inferences to do the conclusion about your population parameter. That's what it's describing here. So let me read those definitions, and if something's not making sense, let me know. A parameter is a number that describes some characteristic of the population. In statistical practice, the value of parameter is not known. And that's why we try to estimate that. And how do we estimate that? We estimate using our statistics. And where does statistic come from? It comes from the sample. So sampling is very important when you are trying to do the inferences around the population. Or how do you do the sampling? So your sampling technique should be such a way that your sample does not suffer from bias, or if it does, you eliminate it as much as possible. As in statistical practice, the value of the parameter is not known. We cannot examine the entire population. Most of the time, when we are talking about something for the population, the population is so big that most of the time we cannot work with the entire population. So instead of working with the whole, we just work with the small part and then try to estimate the population. Statistic is a number that describes some characteristic of a sample. The value of statistic can be computed directly from the sample data, but it can change from sample to sample. And what does that mean? That you can take a sample, you can get the statistic. But once you take the sample, after that, I take a sample or somebody else take a sample. But when I work with my sample, you work with your sample, and other people work with their sample. Not necessary we all get the same statistics. So that's what it says, that the we can compute directly from the sample data, but it will change from sample to sample because it depends what when we do randomization, what sample will we get. If what's and my statistic or my results will depend upon what sample I have or what observations I have in my sample. So that means it will keep on changing depending upon what sample we have. We often use a statistic to estimate an unknown parameter. That's what I said that. So when we are talking about estimating something. In chapter 6, we are estimating our population mean mu. In, chap- in chapter 7, also, we are estimating the population mean mu. But in one case, we know the population standard deviation. The other case, we don't know. So we are going to talk about there. But again, we use a statistic to estimate our unknown parameters. And when we are saying parameter is again a characteristic of the population. And as here it says that S we use for statistic, P for parameter. Statistic come from sample. So they have the first letter same, so easy to remember. And parameter comes from the population. So first of all, you need to identify what is your statistic and what is your parameter. If something is talking about the characteristic of a population, then it is a parameter. So mu, sigma, and sigma square, they said this is population mean, population standard deviation, population variance. So these are my parameters. So mu, if you see the symbol mu, you know that you are not talking about sample, now you are talking about population. Sigma, this is population standard deviation, and that represents population variance. And when we are talking about this, sample mean, so this is my statistic, sample standard deviation and sample variance. Sometimes we say X or Y, and we use these symbols in our chapter 2 when we were doing the regression, when we were looking for the slope, and we were using these symbols depending upon if where my data set is, it's an X is a random variable or Y or Z, whatever I have. So these are your statistic and this is your parameter. And here also they mention like mu, the Greek letter mu for the population mean, sigma for the population standard deviation, and you can add sigma square for your variance. And x bar for the sample mean, S for the sample standard deviation, and S square for the variance. Sometimes the question asks you to find the standard deviation, or most of the time you find standard deviation, but you cannot find standard deviation until you know what your sample variance is. So this one we just discussed. We have the population and we are looking for the sample, collecting the data, work on that, and then use the result to do the inferences around the population. It can be population mean, population standard deviation, variance, whatever we are looking for. The process of statistical inference involves using information from a sample to draw a conclusion about a wider population. Take a sample, work, and then do the conclusion. Different random sample yield different statistics. We need to be able to describe the sampling distribution of the possible values of statistic in order to perform statistical inferences. And we will do the definition in the next slide. The sampling distribution of a statistic consists of all possible values of the statistic and the relative frequency with which value occurs. So when we are talking about sampling distribution have all the possible values of the results that come from your sample and their relative frequency. When you add everything, you can make histograms. And when you make the histogram, then you can look at the shape of the distribution. We plot the distribution using a histogram, just as we plotted a histogram to display the distribution in chapter 1. So sampling variability, what is variability again, and how far it varies. And then we are saying sampling, how far the sample results vary, again, depending upon what is in your sample. Let's say this is the population, we all have one sample, and then we all get a sample mean. And then whose mean we say is better, or whose mean is a better estimate for the population mean. So when we all are getting the sample mean from the sample coming out from the same population, I cannot say my mean is better than your sample mean or somebody else's sample mean is better than this, because we are all working from the same population. So when we get different sample mean, we call it as sample variability. How far each mean, how far or how close each mean from your population mean. And again, sample mean does not have a tendency that it will go exactly same as population mean. It can be over, it can be under, or it can be same. So we cannot say that sample mean is exactly same as population mean. We say that when we keep on increasing the sample size, when we keep on increasing the draw, sample mean gets closer and closer to the population mean mu. And that is the law of large numbers that we learned in chapter 4. So chapter 4, that's why I did not test you on law of large numbers, because we just learned a topic or a concept, but we are applying that concept in chapter 5. So when we are saying sample mean, when you increase your sample size, sampling variability, when we are talking about how what your sample should have high variability or low variability. So when we say that my sample, I take let's say we all take a sample of size 10 and we all get different sample mean. One of us get a sample mean of 2, another get a sample mean of 100. So that means our sample mean varies a lot. And too much variation is also not good in sampling variability. Then we are talking about every single thing from 2 to 100, and that is just the mean. So there are things all around that. So when we want sampling variability, we need to reduce the variability. And how do we reduce the variability? We increase the sample size. So if you remember the third law of principles of experimental design, the third one say that uh, sample size, enough sample size. So when we are saying enough sample size, first one was control, randomize, and enough subject. So when we are saying enough subjects, so sample comes from the subjects, how many subjects you have. If we do not have enough subject, how can we just keep on using the same subjects in the sample? So when you have enough subjects, your sample, you can reduce the sample variability in your experiment. So again, it says that what would happen if we took too many samples, we will get different mean. And then we are going to talk about another law, which says that sampling distribution of sample mean. So now we get sampling distribution. We just get different sample mean. When we say sampling distribution, let's first read that. Anyone has any questions? Half part of this chapter is very conceptual, and the later half, or not the later half, the last part, 5.3 is numerical, but 5.1, 5.2, most of the stuff we have done in the earlier chapter, but we are adding some more, or you can say that the knowledge of previous chapter, we are building more concept on that knowledge in this chapter. Anyone has any questions for me? Okay. So sampling distribution, if we measure enough subject, the statistic will be very close to the unknown parameter that it is estimating. So if we have enough subject, the statistic, if I'm talking about X bar is my sample mean. It comes from the sample. So this is statistic. And I'm saying very close to your population mean. I'm not saying X bar is exactly as population mean mu. So if we say this is wrong. But we are estimating our population mean using sample mean. So we can say that this X bar is a point estimate because it's just one value, point estimate for my population mean. So we are using this value and we are saying this is very close to mu. So we use the sample mean value to estimate our population mean mu. And why we are estimating? Because we do not know the population mean. And when we are saying we are estimating, we need to check if when we are estimating this to use this should not be bias. If this is bias, then your whatever you are estimating is not correct. That will also suffer from bias, or your results will suffer from bias. So when we are talking about sample mean, we again, how can we say that it is unbiased or there is no bias? We learn that we do random sampling. So when we take a random sample, we try to remove as much as possible bias from the sample. And when we try to remove that, our sample should be either having very low bias or no bias. But how can this X bar be an unbiased estimator of population mean? So we will talk about sampling distribution of the sample mean. So let me just talk about this first. If we took every one of the possible sample of a certain size, calculate the sample mean for each, and made a histogram of all those values, we have sampling distribution. That's what we just discussed in the previous slide, that we take a sample from a population, we will calculate the mean of that sample. I take one sample, you take, we all take a sample, we get the mean, and then we make a histogram for all of those values, we get the sampling distribution of all the samples. So what is sampling distribution? Sampling distribution of a statistic is the distribution of the value taken by the statistic in all possible samples of the same size coming from the same population. So these are the three things that we need to think about when we are talking about sampling distribution. So first of all, it should be coming from the same population. If we all are making a sampling distribution histogram, or we are working with the sample, it should come from the same population. Let's say we are talking about UNCG. So the population is UNCG, the sample that I'm collecting coming from UNCG. It is not coming from Guilford College or A&T or somewhere else. So it will be strictly coming from the UNCG. Second thing, when I'm talking about a sample and my sample mean, let's say my sample mean is 40 or 30 or 40 something, and somebody's sample mean is 70 or 80. So we need to check if we are working with the same sample size. If I'm taking a sample size of 10, the other sample should be coming from the population of the same size of sample size 10. So Again, the sampling distribution of a statistic of the distribution is the distribution of values taken by the statistic in all possible samples. So, how many samples you are taking, but they should come from the same population, and each sample should be of the same size. And again, if we are collecting a sample of 1,000 or 2,000, so we are not taking the sample 10,000 times, putting everything in the box layer like there are hundreds of thousands. So we cannot do that. So we do simulations. We use some kind of software. Excel is the easiest one, and you can do Minitab also. That is also very friendly. Again, some of you are from computer science, so you must be using R. So R is also easy. You can generate some random numbers. And again, when you generate and you are saying random, so when you pick one sample, and let's say you are doing again, you will not get the same random sample. Let's say you generate 10 random numbers between 0 to 10. Let's say this you have 0 to 10 and you are generating 10 random numbers. When you generate first time, it will give you some numbers. When you select it again, not necessary you have the same random sample, because again you're talking about randomization. So when you are generating random numbers, we call them, or not generating random numbers, but when you are generating, or when you are generating samples, and we are talking about simulations, so where you are using some kind of software instead of doing it manually, and that will give you the results. And then once you generate, you can calculate the mean, you can calculate standard deviation using the software, and you can done it in any software. And again, I'm saying that Excel is the very easiest one, where you can just give the command how many random numbers you are generating, and if you are looking for mean and standard deviation, you can specify what mean and standard deviation you are looking for. Bias and variability, I discussed this, but let's quickly go over with this part. What is bias and what is variability in the office statistic? Again, when everything is spread out, we are talking about that there is too much variability. When they are together, there is low variability. And when we are saying bias is basically, again, it concerns the center of the sampling distribution. So when we are talking about if we have everything in the middle, then we say that there is no bias, or y in the middle, because our mean is in the middle. So if it is close to the middle or the center, then there is no bias. And this slide explains you using the example of when you have that bull's eye and you throw darts or like arrows on that. Not necessary your arrows are only at one place every time. They will be everywhere. They will be in the center. They can be on the side. So that's how it's explaining the concept of bias and variability, how we can say there is low bias or high bias. And our goal is to have either no or low bias and low variability. So we need both things low. So low bias, low variability, and how can that be when it is close to the center and they are not separated, or they are not spread it out too much. So we can think of the true value of the population parameter as the bull's eye. So that is your true population parameter target on a target, and of the sample statistic as an arrow fired at the target. Bias and variability describe what happened when we take many shots at the target. So you are, let's say you did 10 shots or 20 shots. Do you think all of your shots will be at one place? Maybe somebody's perfect. If that person just keep on practicing or doing it for a long time, maybe all the shots will be in the middle. But person like me who have not done it from long time, maybe mine is all over the places, maybe outside the bullseye or outside this dart too. So look at this first one. The first, before, let me just go over the definition. Sorry about that. Bias concerns the center of the sampling distribution. A statistic used to estimate a parameter is unbiased if the mean of its sampling distribution is equal to the true value of the population of the parameter being estimated. So we said that it is unbiased if the mean is equal to its true value mu. And again, there is no systematic pattern that this sample mean will be exactly same as this. But as we mentioned that if we increase the sample size, our sample mean will get closer and closer to the population mean. The variability is described by the spread of its sampling distribution. So when we are saying bias is talking about the center, and variability is talking about the standard deviation or the spread. So how far it is spreaded around the center or the mean. This spread is determined by the sampling design and the sample size m. Larger the sample size, lower the spread. Smaller the sample size, higher the variability or higher the spread. Statistics from larger probability samples have smaller spread. So if you want less spread or less variability, then make sure you take the larger sample size. So larger the sample size, if the question is just asking you, you are working on something, you're working on a research and you are collecting a sample, what should you do to uh, bias and variability? What do you think? Do you want a higher bias, lower bias, higher variability, and lower variability? So the answer is we want low bias and low variability. And how can we do that? For low bias, we do randomization, and for low variability, we increase the sample size. And again, what should be the sample size? We will talk about that in this chapter as well in later chapters also. If we are saying increasing the sample size, so let's say my population is UNCG, so and I'm looking for a sample size of 100, and I say, oh no, I need to have less variability, so let me say 100,000 or 10,000. Again, we cannot afford to work with such a larger sample. It's not always comfort free. You need to spend your time, you need to spend your money and other resources. So we do not get the sample as big as we want to. It depends, like there are some limitations that comes with it. But again, how to find a right sample size with a particular population, we will work a little bit here but in later chapters also. And this is what exactly we discuss: managing bias and variability. A good sample scheme must have both small bias and small variability. So it's your sample. If you are working with a good, if you are working with a sample, you are collecting, you should have a small bias and small variability. How to get that? Work with the random sampling and use a larger sample. So statistic coming from a simple random sampling, use a larger sample. And we talk about both of these things in later chapter, but now we are connecting those, that how we are working with the sample, which is a good way to work with the sample. The good is we don't need bias, really have as less as possible, and we do not need our sampling distribution to be spread it out too much. The variability of a statistic from a random sample does not depend on the size of the population, as long as the population is at least 20 times larger than the sample. So if you're talking about what should be my sample size, again, we will learn how to calculate that sample size, but sometimes the population is too big and we cannot calculate the sample size with the less information. So just see that if your population is 20 times more than that, then you can take that as a sample. Why randomize? So we did that in the last class, last chapter, chapter 3 and chapter 4. So I'm skipping that part. Just talking about this one, margin of error. Again, margin of error, we will discuss how to calculate margin of error in next chapter. And so just give you an idea, what is margin of error? As the word says, margin of error. So the corner of the error or the endpoints of the error. So we say that when we calculate sample mean, if our sample size is large enough, our sample mean get closer and closer to the population mean mu. So when we are saying sample mean, let's say I calculated the sample mean and it comes out to be 6.5. So I'm saying that my sample mean is my population mean is approximately equal to 6.5. That's what it says. Sample mean get closer and closer to the population mean mu. So when I calculate 6.5, this is my population mean mu, and I'm um, I'm doing random sampling. I'm having large numbers, so I'm doing everything. I get this. So, but when somebody else is doing, that person got 4.2. Somebody else doing 6.9, 7.9, and they are all their population mean mu. So when we are just getting one number or the sample mean, we call it point estimate. So we have one point that estimates our population mean mu. So this is called our point estimate. And since we all are working on the same population, we all are getting different point estimates. If we all need to give the answer, or we all need to work together, whose estimate we should take and whose estimate we can say is better. So when we are working with that, we will do the sampling distribution of the sample mean. So what we do, we will get the sample mean for each, and then we will, this is the sample mean for five of us that get the sample from the same population, get the sample mean, and then we will get the sample mean of means. And in other word, you can say that average of the averages, or sampling distribution of X bar, or sampling distribution of sample mean. And when we are saying that, this will be more close to your population mean. And here, if you notice, we work with a sample of size 10 for the first one, second one, sample of size 10, sample of size 10, sample of size 10, sample of size. So we have five means coming from a sample of size 10. So in together, in total, we are working with a sample of size 50, not just 10. So now we are working with larger samples. So larger sample gives us better estimate. So when we are working with different estimate or different point estimate, we when we are looking for sampling distribution of the sample mean, we take the averages of all those estimates, and that is called your unbiased estimator. So let's say you have some bias here, but when you combine and take the mean of that, and this mean will be much better than their individual mean. So this is called your unbiased estimator of population mean. Sampling distribution of sample mean is much better, or it's that's why we said that so far we are saying there may be bias, but we are trying to remove as much as possible by doing the randomization. So we are doing all these five samples, but then we are taking the mean of all these means, and that will be as close as this, that will be closer to your population mean. So that is your unbiased estimator. So if you see the word unbiased, we are talking about the same thing, no bias. We are having no bias. But when we work with the larger samples, and again, we are saying that we work with the sample, larger sample of size 10, and we get a sample mean for each sample, x1, x2, x3, x4, x1 bar, x2 bar, x3 bar, and then again take mean. So you are taking mean twice. You take the sample mean, and then the statistic that you get after taking the sample mean for each, then you will find another sample mean. And that will be very close. So this is your point estimate. So point estimate just give us one value. And there is another thing called interval estimate, and we will talk that in chapter 6 and 7. But what is that interval estimate? Whatever my point estimate is, I will add and subtract, or I can add and subtract, keep some room for error on both sides. So if I am having 6.5, so let's say 6.5, let's say I will say that there is some room for error, let's say 0.5. So I am adding zero point 0.5. And when I'm adding zero point 0.5, I'm subtracting that zero point 0.5 too, because we have this negative sign. And when I'm subtracting, now I'm not just saying 6.5. Now I can say that my population mean is in this interval between 6 and 7. It can be either 6, it can be 6.1, 6.111, 6.3, 6.9, 6.999, or 7. So it is somewhere in this interval. And that is called my interval estimate. And that is your margin of error. Again, we cannot just add error from our side. We can calculate error depending upon what information we have. So we will cover that in our later chapter. So I kind of covered this part also, this part, and this is the only thing that is left. So let's just quickly go over with that. Population distribution of a variable is the distribution of values of variable among all individuals in the population. So that's what we are talking about, population distribution. The population distribution is also the probability distribution of the variable when we choose one individual at random from the population. And this slide also telling you one thing, that sometime let me just read this. In many examples, there is a well-defined population of interest from which simple random sample can be drawn. As when we sample students who attend a particular university like UNCG we just discussed. But sometimes the population of interest does not even actually exist. Um, but we try to work with that using some samples from the past, like how it says that sometimes the population of interest does not actually exist. For example, the exam scores of student who took a course last semester can be thought of as a sample from a hypothetical population of students who will take the course in the future. Let's say I will use your exam results and work on that and get, and I can, once I get my statistic, I can use that the students who are taking classes from me from 2015 to 2021, I look at their averages. For test 1 is between this to this range, test 2 is this to this, or letter grade from A to B is this, and I can use that information. It's like, okay, for the next coming students, for 271, it will be in this range. So again, that population is still not there, but we can take the sample from the previous one and then we can talk about the future one. But that population of student does not exist. We can still think of the observation as having come from a population with a probability distribution. Mean and standard deviation we discuss. There is no tendency of sample mean to fall systematically above, below mu if the distribution of the raw data is skewed. Thus, the mean of the sampling distribution is unbiased estimator of a population mean mu. So we talk about so far, so your sample mean get closer and closer to your population mean. What happened to your standard deviation when you increase the sample size? And we say that when we increase the sample size, the variability is low. And when we are saying variability is low, when you increase the sample size, your sample mean gets closer and closer to your population mean, and your standard deviation gets smaller and smaller when you increase the sample size. We discussed that variability goes down, and down by how? So this is my variance, variability, and then it goes down by how much we increase the sample size. So if this is my variance, my standard deviation is sigma over square root of n. So your standard deviation goes down by square root of n. Your sample mean gets closer to the population mean, so x bar is this. But what is my standard deviation? My standard deviation is not this anymore. It is standard deviation divided with my sample size. Whatever my sample size is, do the square root y, because we are talking about variance, and this is the standard deviation. So this is what it says here. And central limit theorem is the most important thing in this chapter, so I really don't want to start this topic now. So I will talk about this once we are done with central limit theorem. The next topic we have binomial distribution and Poisson distribution, and then we will be done with this chapter. Your assignments are open. Your stat tutor videos are assigned to you guys. So guys, make sure you work on it, and let me know if you guys have any questions. And I'll see you guys on Monday. Thank you, everyone.
Thank you.
You're welcome.